So one of the things that we did is we actually covered most of the logarithm. You guys already know how to, with the integral of the log of x is. You already know what the derivative, well, not the integral of log of x, the integral of 1 over x. You already know the integral of 1 over u. You know certain things. So much of this I don't even have to cover in this section, and I won't because it's review. But I want to say just a few things about this. Okay, so I'm going to give you, so the first problem I want to look at is, let's say we are integrating 4x over 6x squared plus 9 dx. Now, one of the things that I recognize as I go to do this problem is I think I need to do this by u substitution. Can anybody give me an idea? Okay.
Do you have to factor out the bottom first?
No, you don't. You don't have to factor it. You can leave it just like it is. Factoring it just adds more work to it. So we're going to leave it as it is. I'm going to use the fact of something that we've already learned. Okay. So what am I going to let be u?
Professor, can you not hear me?
I can hear you, Diara.
Yes.
Okay, what did you say?
You will be 6x squared plus 9.
Okay, so I want to let u be 6x squared plus 9. Diara, can you continue with this problem, please?
Du is 12x dx.
12x dx. And, oh, forgot my x. And then what am I going to do?
Then you'll find dx, and dx equals 1 over 12 du.
Okay, so I'm going to let 1 over 12 du. That's going to be x dx. Because in my problem, I have x dx. Okay, so I need to solve for that. Okay, so that's going to be in my problem. And so actually this problem is very simple. We can move the 4 out. We have the integral of x dx divided by 6x squared plus 9. Okay, what do I do now?
You then substitute. You will have you have 1 over 12 du over u.
Okay. All right, so now the 1 over 12 comes out and gives me 1/3. The integral of du over u. Now you guys should recognize that right away. We've already done this. We actually did this section several weeks ago. What is the integral of du over u? Okay, so that's what I thought. You guys don't remember this too well. Okay, so let's just go back for a minute. So let's consider, I am not going through all this. Consider y equal to the natural log of x. The derivative of y with respect to x is equal to what? What's the derivative of the log of x?
1 over x.
1 over x. Very good. Okay. If y is equal to the log of u of x, what is dy dx?
One over ux.
Okay. But I need the chain rule. So what other piece needs to come? I got to differentiate what's inside, and what's inside is u, right? So this goes way back. The derivative with respect to x of the log of x squared. You put the x squared in the denominator, and then you multiply by the 2x, and you get 2 over x. You guys got to remember this stuff. Whoa, you got to remember this stuff. Okay. It's the integral of 1 over x squared dx.
Two x over x squared.
Not quite. Is that Gustavo?
Yes.
Okay.
Is
Does this help? Okay. We remember that the integral of x to the n dx is x to the n plus 1. You know, I tell you, I truly believe something went wrong in Calc 1 that you guys don't know this. It's actually scary to me. Okay, so this is simply going to be x to the -1 divided by -1 plus a constant. But that's just 1 over x, -1 over x plus c, because we use the power rule. But this is only true if n is not equal to -1. But if I have the integral of 1 over x dx, what is that?
Would it be ln of x?
Good. It is the natural log of the absolute value of x plus the constant. Thank you. Okay. And what is the integral of du over u?
Ln absolute value of u plus c.
Okay, so now we have these formulas. Okay. All right, so let's go back to our problem, which was here. Number 1. Okay, we're gonna finish number one now. So how do I do that integral?
So would it be 1/3 ln of absolute value of u plus c?
That's correct. Okay, but what is u?
6x squared plus 9.
Okay. Cameras on, with the exception of the one person who sent me a text. Well, all the rest of y'all need to have y'all cameras on. It's only one person that's allowed to have their camera off right now. Logan, how do I do this problem? Logan. Okay, Logan's not here. Lawrence, how do I do this problem?
I guess the first thing you do is define u and du.
Okay, very good. So what's u?
U is 3 minus x to the third.
Okay, and what's du?
I'm not sure.
Okay. Who was your Calc 1 teacher?
I don't remember her name.
I think I know who it was. Somebody, okay, Lawrence. So I need somebody that's going to help Lawrence get the derivative of this function.
Professor,
Yes.
would du be negative 3x squared?
Negative 3x squared dx. Okay.
And then x dx would then equal to, well, x squared dx would then equal to negative 1/3 du.
Okay, keep going.
Then you will have factor out for over u, which is in this case 3 minus x to x cubed. Negative 1/3 du. Then you take out the negative 1/3, which will then just give you 4/3. -4/3 natural log the absolute value of 3 minus x cubed plus c.
Okay, is this getting any easier, guys?
Yes.
Yes.
Yeah.
Elisha. What do I do?
Take out u, which is
Okay, so which u gonna be?
tangent x plus 6.
Tangent x plus 6. So what's du? It's the derivative of the tangent.
The secant
Secant
square x.
okay.
I don't really know what's after that.
Say that again.
I said I don't know what's after that.
Okay, so have you ever asked somebody for a case quarter? Y'all know what a case quarter is? Oh,
No.
y'all don't know what a case quarter is. That was, who knows what a case quarter is?
Is that an old school thing?
It's an old school thing.
Oh yeah, I don't know that.
Okay, so when I was young, if I wanted to, I needed a quarter maybe for the parking machine or whatever, and it didn't take nickels and dimes, you
Mhm.
ask for a case quarter. So somebody's walking by, you say, you got a case quarter? So they hand you a quarter and you give them 2 dimes and a nickel, or you give them 5 nickels or 2 dimes and 3 nickels.
Name of Pete, the way he was walking to, but it's relevant.
But a case quarter,
I mean,
You can make it cool.
okay, somebody needs to mute. Okay, so a case quarter is the exact same thing as 2 dimes and a nickel, 1 dime and 3 nickels, or I could have 1 dime and 15 pennies. It doesn't matter, but it is a direct, complete substitution. So I need a case quarter and you have 2 dimes and a nickel. So we actually just say they are equal to each other. I can replace the 2 dimes and the nickel with the case quarter. Everybody know what I'm talking about? Okay. Where's Elisha? I don't see him. Trying to find him. Got to find his face. There he is. Okay. Now what I need to do is the same thing that I would do with that case quarter. I need to make an equal exchange. Okay. So now when I look at the paper, I see that I went through the work to make u equal to the tangent of x plus 6. So where I have the tangent of x plus 6, I take and I do my equal exchange and put a u there. Like I'm asking for a case quarter. They're the exact same thing. Okay, Elisha, what do I do next?
So you gotta put secant square x on the other side.
Okay, so
Or secant
now I
squared.
have secant squared x dx, and that looks like this. So now I swap out another case quarter and I get that. Okay, so do you see the direct substitution of what I've put on the right-hand side of the problem with what was originally in the left-hand side of the problem?
Mhm.
Okay, so now what's the integral of du over u?
ln u.
Good.
Natural log of u plus,
So this is the
constant.
ln of the absolute value of u plus a constant. Now, here's the thing. I go and meet somebody else and now they need a case quarter. So now we need to do that swap again. What is u?
Tangent of x plus 6.
That's the end of the problem. Do you guys see that?
Yes, ma'am.
Okay, gonna do one more. Antoine, what do I do? Antoine? Hello?
Yes.
Okay, so I'm looking for something that looks like that it could be a u where its derivative is somewhere in the problem.
Okay. You would set u as 4x plus cosine x minus 9.
What's du?
Du would be
What's the derivative of 4x?
I think would that be 4? I think the du would be 4 minus sin x, right?
Yes, it is. In parentheses, dx. Everybody see that now? Okay, who wants to finish the problem? Antoine, you want to finish it? Yes.
So our next step would be integral du over u equals ln absolute value u plus c, and that'll equal ln 4x plus cosine x minus 9, and absolute value plus c.
Okay, are we good, guys?
Wait, the only thing I'm confused about is why did we not further simplify it to have it be dx equals 1 over 4 minus sine x, considering that the dx is positioned not within the fraction itself?
Because this whole thing right here is exactly this. There's nothing to do.
Also, the dx is supposed to be positioned within the numerator of the fraction.
Well, if it's, as long as it's multiplied, it's in the numerator. Dx is never in the denominator, never, ever, ever.
Okay, thank you.
You're welcome. What do you think, guys?
Can I try this one?
What's that?
Say, can I try this one?
Yep.
So u would be x squared plus 36. Du would be 2x dx. Then dx was equal, well, x dx would equal half times du.
And what's the problem?
And then you have the integral of 4 over u dx.
1/2 du is equal to x dx. So you have the integral of 4, and then you have 1, just dx over
u.
Okay. What's the problem?
Can't make like a equal exchange, equal substitution.
Okay, so Deara, I understand you looking at it like, uh-oh, something wrong. That's right, something is wrong there. So can I get a case quarter out of here? I don't have an X, right? Okay, so this problem cannot be solved the same way because it's missing an X. So this is not going to work. Do you know what the new other technique is? I promise you, I taught it to you.
Use the integral of tangent.
Exactly. So here I'm going to let a squared be 36. And so a is going to be 6. And this is a direct integral from the last test. This would be 4 times. This is going to be 1/6, the tan inverse of x over 6 plus a constant. So this is going to be 2/3 the tan inverse of x over 6 plus a constant. So Deara, you started off exactly the way everybody would probably start the problem off, because the type of problems we've been doing are of that form. So when you get to this point, just like you looked at it and said, what am I supposed to do with I saw your face. What am I supposed to do with that X? That's when you know you have to use another technique. But the way you started off was perfect. But then you realize that there has to be another way to integrate this problem. Okay. All right.
Hey, can I get a picture of that real quick, Professor?
Say that again.
Could you go up a little bit for me again, please?
I can.
Right there's fine.
To here.
Yes.
Oh,
Alright.
geez, I'm sorry. What's the integral of e to the x dx?
Doesn't it stay the same?
Pardon?
Doesn't it stay the same?
It stays the same. What's the integral of e to the u du?
EU plus C.
Okay.
So any integral of E just has the same thing plus C?
As long as it is just e to the x dx or e to the u du.
Okay.
Okay, has to be e to the x dx or e to the u du. Okay. Now we did these problems. This section is a review. We did these. Remember, we even did a to the x. We had a, like the integral of 5 to the x. We did all those other crazy ones. Okay. What is u?
Is it x squared?
It is x squared. And du?
2x?
Okay, so what do I need to do?
You will have to substitute.
Okay, we're going to substitute. Okay. So I see x dx in the problem already. I see it. Here's x dx. I already see x dx. So we need to solve for it.
1/2 du.
Okay. So this is 3 times the integral of x e to the x squared dx. You want to go ahead and finish it?
Ooh. Okay, so then you had 3 times half, which would just give you
Where'd the half come from?
xd. So you have x dx in the equation. So then we have x dx equals half times du.
Okay. And then what do we have? E to the,
You have e to the u.
good. Now let's write it like we know we should. 3/2, the integral
Which would just be 3/2 times e to the u.
plus a constant.
That's a constant.
I gave you the problem in x. I don't want it in u. I need you to go back.
So then you'll change it to e to the x squared.
Am I finished?
Yes.
Yes. EJ. How you doing there? That Eagles
I'm
hat?
hanging in there.
That's the Eagles hat?
Not that's the Seahawks hat.
Oh, okay. I like them too. Okay. Do you have an idea where we go, where we start? Okay. All right. So first off, the things that we got to remember, no, put your mic back on because you're going to talk to me. Okay. So the first thing we have to try to remember is looking at, I don't know where you just went. You just disappeared. I was looking at you.
I'm still here.
Yeah, but I don't see you. Hold on a minute. Somebody must have, the camera. Oh, there you go. Okay. All right. I'm looking at all of y'all, but trying to see you too. All right. So I need to be able to figure out when I have the base E, I know I have e to the x is its integral is still e to the x, and the integral of e to the u du is e to the u. So all I need to do is make this problem look like e to the u or e to the x. Now, obviously, it's not going to look like e to the x because I have cotangent. But I can say if this were e to the u, I could integrate it. So what am I going to let u be?
Is it gonna be the stuff right there that's highlighted? The 3x.
Oh, no, we're in a different problem. The problem we're looking at right now.
See, we at 7.
Yep, we're at 7. Okay.
Okay.
So I need e to the u. So what's u going to be?
E to u. Would it be the COTX right there?
Okay, that is the cotangent. Yes, it would be. So let u equal COT. That's the cotangent of x. If you don't remember, the cotangent of x by definition is the cosine of x over the sine of x. That's its definition. Okay. Okay, from trig. Okay, so u is the cotangent. So now I need to find its derivative. So what is the derivative of the cotangent? This is one of those derivatives that I told you, you just have to know like this.
Secant squared of
Would
x.
it be the CSC squared thing?
Okay, so that is negative cosecant squared. So the derivatives of the cos are all negative. Okay. So since the derivative of the cos are all negative, it looks like I can almost substitute everything out, except I got one little annoying thing in there. What is it?
The negative.
The negative. Good. Okay. So this is going to be u. And then du is going to be the cosecant of x dx. So when I do that, again, that's like me asking for a case quarter. I'm substituting 2 dimes for a nickel. It may not be the same, but it's actually worth the same thing. So now when I come over here and I find the cosecant squared of x, then I'm going to divide. So now I'm going to get the cosecant squared of x dx is equal to divide the other side by -1, I get negative du. Okay, so at this point, everybody should be able to finish the problem. Everybody should be able to finish the problem. So what's the answer? Somebody just want to give me the whole answer, the end? What's the end?
Would the answer be negative e to the cotangent x plus c?
That's the final answer. Okay. Anybody not know how to get there? Anybody not?
I don't know how to get there.
Okay, I'm trying to see who's talking. Hold on. Who said that?
It was Lawrence.
Lawrence. Okay, Lawrence, thank you for asking because you're not the only one. Okay, so now we're going to substitute back. Case quarter. The blue is so E, I'm going to have the integral e to the cotangent of x. Well, the cotangent of x is just u. See here? And then I'm going to substitute this cosecant x dx. Well, that looks like that. Uh-oh, that's the wrong arrow. That should have gone here. Okay, so that is just a negative du. Lawrence, you with me?
Yes.
Okay, so then I subtract this out and get the integral of e to the u du. But we know this one. This one is known. It's one of the nicer ones. It's one of the easier ones. Okay. What is the integral of e to the u du? Lawrence.
Didn't you say it would just be the same thing? So
There it
plus
is.
C.
E to the u plus a constant.
Okay.
So this becomes negative e to the u plus a constant. Then I go back and say, what is u?
Cotangent x.
That's right. Okay, any questions?
No, thank you.
All right. Is this help? Is this section, I slowed it down today just a wee bit. Has this helped anybody with their u substitution integration?
Yes, a lot.
Yes, ma'am.
Yes.
Okay, one more before we go. This one was on the test. You should have known this one. That one's on the test. I'm gonna let y'all think about that while I take roll. How do I do this problem? U is tan inverse of x. What's du?
Going to be 1 over x squared minus 1.
No.
Plus 1.
Yes, very good.
Dx.
Okay, so then what do?
You can, that means dx would then equal to, some telling me 1 plus x. 1 plus x du.
Actually,
No, not 1 plus. Yeah, no, yeah, 1 plus x du.
You can leave it just like it is though, darling. Look,
Okay.
This is dx in the numerator over top of 1 over x squared. This is dx in the numerator over top of 1 plus, oh shucks, that should be x squared. Okay, so it's already there. Don't have to do anything. Keep going.
You then would change it to EU over. Do you do over? No, you don't do over.
Let's just do EU, DU.
It's just times du. All of this is just this.
All right, so then you would just, then it would equal to E of 10 inverse of X. Plus C.
Awesome. Okay, tomorrow we're going to do more. Okay, so for the next couple weeks, we're going to be learning a whole lot of integration techniques. I need you guys to practice, practice, practice. Okay. Because if you don't know the basic integration, you are never going to be able to do these this whole next module. This next module is going to be significantly difficult if you don't know the basic derivatives and integration. Okay. All righty, guys. I will see you tomorrow.